Good afternoon, everyone. Welcome to the second last week of this course. I hope that you all had a great weekend and that you're doing well today. We're looking today at lesson 30.23, which deals with factorial notation, which we are already a little bit familiar with because I talked about it a bit during Friday's lesson. And we're also going to be dealing with something called permutations. And this is part A of the lesson because we're going to continue our work in this section on Wednesday. The lesson can be found on page 31 of your current lesson handout. So let's review what factorial notation is all about. If I gave you the task of arranging 7 books on a shelf, and you use the fundamental counting principle to find out how many different ways that can be done, what your reasoning would sound like would be, I need to choose one of 7 different books to put in the first position, so I need to multiply 7 by the number of different books I can decide to choose from for the second position. Well, you've already chosen one book for the first position, which means you're down to 6 for the second. And then you're down to 5 for the third, all the way down the line until you get to the end, and you only have one more decision to make, and it's what book do you put in the last position? But at that point in time, you only have one book in your hand. So the number for the last blank would be 1. And we abbreviate this product by writing 7 factorial, 7 with an exclamation point. And what it means is 7 times 6 times 5 times 4 times 3 times 2 times 1. So in general, n factorial means you're going to take n and multiply by 1 less than n, and then multiply by 1 less than that, and 1 less than that, and you're going to continue to keep subtracting 1 until you get down to 3 times 2 times 1. So as a warm-up, calculate each of the following. What is 5 factorial? Well, again, I've shown you how to do this. You don't need to enter 5 times 4 times 3 times 2 times 1. What you can do is enter 5, go to your math menu and scroll over to your probability submenu and choose option 4, and 5 factorial is 120. When you calculate 10 factorial, you get 3,628,800. And the only reason why I have this in here is to get you used to using your calculator with the factorial. Now explain why 150 factorial over 148 factorial is equal to 22,350. I want to show something to you right now that if we tried to do this on our calculator, what would happen? 150 factorial divided by 148 factorial gives me an error. The error is called overflow, and what that means is the number is too big. Now, it isn't that the answer is too big, it's that 150 factorial is too big. If you try to calculate 150 factorial or 148 factorial, you get the same error. What that means is 150 times 149 times 148 times 147, all the way down the line, is a number that's too big for your calculator to handle. So how do we go about evaluating this? So what we're going to do is start expanding 150 factorial. 150 factorial means we're going to take 150 multiplied by 149 multiplied by 148 multiplied by 147 multiplied by 146. I'm not going to do all of these. Multiplied by eventually 3 times 2. And I know that we don't need to write the number 1, but I like to put it anyway. Now this is over 148 factorial, but this is 148 factorial. Everything from the 148 times 147 times 146 all the way down to 3 times 2 times 1 is exactly equal to what we have on the bottom. And that means we can calculate this by canceling the 148 factorial on the bottom with the 148 factorial on the top, and being left with 150 times 149. And of course, if we calculate 150 multiplied by 149, we get 22,350. So I don't know what you want to write for an explanation here. I don't think you need to write anything. The explanation is, and this is very important to what we're going to be doing today, that the 148 factorial is contained as a factor in the 150 factorial. And when you cancel that 148 factorial as a factor in the top and the bottom, you're left with only two numbers. And I really want to drive this point home in a different way. The smaller factorial is always contained in the bigger factorial. So 148 is a smaller number than 150. 148 factorial will be inside of 150 factorial. So let's apply this now to algebraic expressions. If we're asked to simplify n factorial over n minus 2 factorial, what we're going to have to do is expand one of these factorials because the other factorial will be contained within it. Remember that when we had 150 factorial over 148 factorial, it was the 150 that we expanded. This was what we expanded. And the reason we expanded it was because it was a bigger thing than 148. And when I take a look at n over n minus 2, both as factorials, n is a bigger number than n minus 2. So in our warm-up, 148 was contained as a factorial within 150. In this question, n minus 2 factorial will be contained within n factorial. So I'm going to start expanding n factorial. So what is n factorial? It's n multiplied by one less, multiplied by another less, and another less. How many of these you choose to write is not that important. We're eventually going to get down to 3 times 2 times 1. Now on the bottom we have n minus 2 factorial. But when you take a look at the top, there's an n minus 2 factorial on the top. On the top, as part of what's there, you have n minus 2 times n minus 3 times n minus 4 all the way down the line to 1. And on the bottom, you have an n minus 2 factorial, which means that this n minus 2 factorial and this n minus 2 factorial cancel with each other, and you're left with n multiplied by n minus 1. If you wanted to, I suppose you could expand that out and write n squared minus n. But that is our answer. B, n plus 3 factorial over n factorial. Well, which of those is bigger? N plus 3 is a larger number than n, which means the smaller factorial this time is the n factorial. The n factorial will be contained within the n plus 3 factorial. We're going to start expanding the n plus 3 factorial because it's bigger. So it's n plus 3 times 1 less, which would be n plus 2, times 1 less, which would be n plus 1, times 1 less, which would be n, 1 less. And what you want to do is write enough of these so that you see what will cancel. This is over n factorial. Well, n factorial, which is what we have on the bottom, is this, which means those two things cancel, and what you will be left with is n plus 3, n plus 2, n. And I don't feel the need to multiply that out. This is our answer. C, simplify n factorial over n times n minus 1. Be careful here because that's not a factorial on the bottom. Let's start expanding the numerator as a factorial and see what happens. N factorial is n times n minus 1 times n minus 2 times n minus 3, all the way down the line again until you get down to 4 times 3 times 2 times 1. I don't know that you really need to write that last part of it. You could just put dot, 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 but you need to know it ends at 1. Now on the bottom we have n times n minus 1. Well, what we have are some common factors. You have an n as a factor on the top, and you have an n as a factor on the bottom. You also have an n minus 1 as a factor on the bottom, and you have an n minus 1 as a factor on the top. So if you were to cancel those common factors, what you are left with is n minus 2 multiplied by n minus 3 multiplied by n minus 4 all the way down the line, which means n minus 2 factorial is our answer for this one. All right, now what we're going to do is look at what a permutation is. A permutation is an arrangement of items, and the word arrangement means order is important. If I ask you to arrange the letters of the word bat, and you switch some letters and you get the word tab, these are different. So order matters. You might be sitting there wondering, well, when would order not matter? Don't worry about that. We'll get to that later. That's called a combination. So a permutation is simply an arrangement of a number of items, and that means that order is important. Determine the number of permutations of all of the letters of each word. Well, we have a total of 6 letters in the word Regina. So if I were to use the fundamental counting principle, I would get 6 times 5 times 4 times 3 times 2 times 1. I would get 6 factorial, which I believe is 720, but I don't really care what the actual value is. If I said to you, how many different ways can you arrange all of the letters of the word Ashmont? Since there are 7 letters, you would have 7 blanks with the fundamental counting principle. And when you multiply out 7 times 6 times 5 times 4 times 3 times 2 times 1, you get 7 factorial. And I don't know what 7 factorial is. And notice that the number of permutations of n letters taken all at once is n factorial. What this is saying is something you should have learned already. If you're going to arrange a certain number of items all in a row, the answer is the factorial of the number of items. If I had 12 people that are going to stand in a line, there are 12 factorial ways of arranging them. But what happens if we're not going to arrange all of the items? What happens if we have a group of items and we're going to just choose a small subset of that and we're going to arrange them? So for example, what if I said we have 7 different people and I'm going to choose 4 of them to stand in a line? How many different ways can that be done? How many ways can I arrange 4 people out of a total group of 7? Well, the number of ways of doing that can be abbreviated using that notation. Let me just write that a little bit larger. The 7 and the 4 are both subscripts, and then the capital P is written on the main line of text, and that is pronounced 7P4. And the P means permutation. So we are arranging 4 items taken out of a group of 7. Well, it turns out that there's a formula. If you have n items and you want to arrange them in groups of 4 at a time, you can do so by using n factorial over n minus r factorial. And the next example will illustrate why that formula works. Example 3 says we have the letters from the word Ashmont, and there are 7 different letters, but we're going to arrange them in groups of 4 at a time. The fundamental counting principle says if I wanted to know how many ways to arrange 4 letters out of that group of 7, I would put a 7 here because I have 7 different letters to choose from for the first letter of my arrangement, and then I would have 6 and then 5 and then 4. And of course, just like Bobby Bear selecting a shirt and a pair of pants, we have to multiply our options here. And what we get is 840. Now, why does the formula that I showed you a minute ago work? Let me write down the formula again. It says NPR equals n factorial over n minus r factorial. All right. Well, in this case, it's 7p4. So n is 7. This will be 7 factorial over, on the bottom, we will have 7 minus 4 factorial. That gives us, for 7p4, 7 factorial over 3 factorial. But 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. And on the bottom, we have 3 factorial, which is 3 times 2 times 1. We are back to the canceling of a factorial, 3 factorial, which is contained in both the numerator and the denominator. And what you're left with is 7 times 6 times 5 times 4, which again is 840. So that's why the formula works. By the way, what I'm about to tell you is not really that important for how you solve the problems, but we have to say that 0 factorial is 1. By definition, 0 factorial is 1, and you could check it out on your calculator. The reason for that is if I go back to arranging all of the letters from the word, say, Regina, we know the answer has to be 6 factorial with the fundamental counting principle. But according to the formula, it would be 6p6, which would be 6 factorial over 6 minus 6 factorial, which would give us 6 factorial over 0 factorial. The only way that 6 factorial, which we know is the answer, can be equal to that is if the denominator of that expression, 0 factorial, is 1. So if you ever run into 0 factorial, it's equal to 1. In a particular country, license plates consist of 2 different letters followed by 4 different digits. Find the total number of possible plates using the fundamental counting principle. All right, so the license plate has 2 different letters followed by 4 different digits. The fundamental counting principle says the number of ways that you can choose each of these pieces multiplied together will give you the number of ways that you can choose the whole plate. So we have 2 different letters. Well, there are 26 letters in the alphabet, so the first letter can be any one of 26, and the second can be any one of 25. Then we have 4 different digits. In our mathematics system, there are 10 digits, 1 through 9 and 0. We have 10 different choices for the first position, then 9, then 8, then 7. So we have to multiply these numbers all together. 26 times 25 times 10 times 9 times 8 times 7. Which gives us 3,276,000. That's our answer. What does it mean when it says use permutations? Well, we're still going to use the fundamental counting principle, but in a very broad sense. We're going to say there are two things you need to do. You need to arrange two letters, and you need to arrange 4 digits. Well, how many ways are there to arrange 2 letters out of 26? 26, P2. How many ways are there to arrange 4 digits out of 10? That would be 10, P4. So if we can calculate 26P2 and 10P4, we can multiply them together. Now, I am perfectly aware that 26 times 25 is 26P2. And 10 times 9 times 8 times 7 is 10P4. But that's not how we're going to calculate them in Part B. What we are going to do is use our calculator. If I enter 26 and then go to my menu where the factorial notation was, I discover there is an NPR function. And then I can enter 2. By the way, you do not need a set of brackets around any of this, because as soon as you pull up NPR on your calculator, the 26 and the 2 are locked together. This will be equal to the 26 times the 25. Now I can multiply by 10P4, and I get the exact same answer, 3,276,000, which is our answer. And this is a lot slicker doing it with permutations in your calculator, because if the number of different stages becomes more complex, then writing out a bunch of blanks becomes very tedious. That's it. Your assignment is on the next page, question 1, 2, 3, 6, 7, 9, 12, and 13. Don't forget that your final weekly assessment is due today by 3:15. Also, don't forget that your final assessment has been given to you already. I believe I gave it to you on Saturday, and it is due on June 19th by 3:15, and neither of those assignments will be accepted past the due dates and times. So it's important that you organize yourself and you get things done when they should be done. I hope that you guys have a fantastic rest of the day. Hang in there. There's only a couple more weeks. I know that this is difficult at times. I'm finding it difficult at times as well, but we will get through it. So have a fantastic rest of the day and take care of yourselves. We'll talk to you soon.